Yes, still on this circuit we can please you have to watch the previous video to understand at this point. Still on this circuit we decided that we can actually do this, representing this as the graph of this circuit where we have this. We have 1, 2, 3, 4 nodes. We have the branches. This is 3. This is 2. This is 1. This is 6. This is 5. And this is 4. This is 4. So we also established that a subgraph where all the nodes are represented, we call that tree. So we decided that if we can also keep this as a tree. So where this is 1, this is 2, and this is 3. This is 3 from the diagram, and this is 4. So we have varieties, so many ways of writing our tree from the graph. Please, we have to make sure that all the nodes are presented. So in this case, let's just try and see how many trees are possible from this graph. So we have branches, the links are the missing branch, the links. We have 1, that is, we have 1. We also have 3. We have 3 that is missing, and finally we have 5. 5 is missing. And the twist, we have 2, we have 4, and we also have 6. So we want to find out the number of trees that is possible from this graph. Now, having done that, we have to consider the number of nodes to consider is n minus 1, where n is the number of nodes that is present in the given graphs. So in this case, we can represent this a graph or a matrix form that has this 1, 2, and 3. And we have to also take the twist where we have 2, we have 4, we have 6. And the links will come after. We have 2, we have 1, we have 3, and we have 5. So let us see the relationship between the nodes with the branches. So this is 1, and what is it with 2? 2, according to the arrow, we have this, we have this. According to the arrow, branch of 2 with respect to node 1 is 1 because it's moving away, and also branch 4, this is branch 4, and to 1 is 0, they don't have any relationship. And also branched 6 is also 0. What about 1? 1, of course, even if it's not there, you can still write something, and that is minus 1. And what of 3? 3 is away 2, we have minus 1. And also finally we have 5, we don't have any relationship. So we have this. And the next one is to consider is this node, and the relationship between these 2 and 1 is 0, and also between the 2 and 4 is 1, and between the 2 and 6 is 0, between the 1 and 2 is 0, between the 3 between the 3 um, between the 3 and 2, sorry, this is -1 is moving towards it. Between the 1 and 2, no relationship. Now between the 3 and 2, no relationship, we don't have any relationship. And between the 5 and 2, -1 is moving towards the node. So finally, of course, we are using 1 minus 1 node to find out the number of tree that is possible from a given graph that we generated from a circuit. So finally, we have this to consider, and 2, so that is 0. And we also have 4, so this is 0. We have 6 is 1. We have 1 is 0. We have 3. 3 to 3 minus this, 5 to 3 is away, so it's 1. So we finally have a matrix that we can use to generate the number of the tree that is possible from a given graph. Let's do a recap. You have to present the twist 2, 4, 6, 2, 4, 6, and the links 1, 3, and 5. And this you consider 1 minus n minus 1 node. So you have 1, 2, 3. Ignore the last node, and also consider the relationship. First of all, we have 1 to 2, and see it's moving away. We have 1 to 4, no relationship. 1 to 6, no relationship. 1 to 1 is moving towards it, and 1 to 3, 1 to 3. Please, this is moving away from it, so it's 1. And also 1 to 5, no relationship is 0. So let's look at 2. Note 2, we have this, and 2 to 2 is -1, it's moving towards this. 4 is moving away from it, that is why it's 1. And 6, no relationship. 1, no relationship. 3, no relationship. But 5 is moving towards 2, and that line is correct. Finally, we have this to consider. So this is 2, branch 2, no relationship. We have 4, no relationship. We have 6 is moving away from node 3, and 1, no relationship. We have 3 is moving towards 3, -1, and we have 5 is moving away from, it's moving away from this. So that is how it is. That is how it is. But we can actually take this to be this, where we've said that 5 to 3 is -1. That is moving away towards this node. No matter how you take your direction, you always have a particular values. So in this case, we've come to realize from this diagram this circuit, and we call this circuit A. So we can actually write it out, that A is equals to this 1 minus 1, this. We have this 1, 0. We have 0, 0, 1. We have -1, 0, 0. We have 1, 0, minus 1. We have 0, minus 1, and 1. So having generated the matrix, we want to say that the number of matrix is A dot A transpose. So we are actually saying that if you multiply your A, this is A, multiply this 1, 0, 0, this, minus 1, 1, 0, 0, 0, minus 1, you have 0, 0, 1, 0, minus 1, and 1. If you have this multiplied by the transpose of that same graph, transpose is when you this will come first, 1, 0, 0, minus 1, 1, this. The middle will take this, 0, 0, 0, minus 1. And also you have 0, 0, 1, 0, minus 1, and 1. So when we multiply this, we are going to have a 3 by 3 matrix. So at this point we have this times this, which is equal to, and when we multiply this and this, we are having this times this times this times this, so this will be 3. So that is this, that is 1, this and this will be 0, this times this, that is 1 plus 1 is 2, we have this times this, that is 3, this is 0. We are done with that. So the next one is that we consider this and this. So this times this minus 1, and we move from here to here. We are having 1, 2, 3, 4. So 1, 2, 3, 4. This. So this times this minus 1, this times this 0, this times this 0, this times this 0, this times this 0, and this. So this will be minus 1. So we have on that row this times this times this 0, this times this 0, this times this. So we have this times this minus 1. So that is still minus 1. And we consider the middle row. They're going to have this times this minus 1, this times this times this times this times this, and this. So we have a minus 1 on that. So we have this times this times this, that is 2. The whole of this is going to be 0. We add this, so that is giving us 3. So on that, still have this times this 0, this times this 0, this times this 0, this times this 0, this times this 0. The final one we have minus 1. So finally we have this times this times this times this times this times this, and this times we have minus 1. So that is this times this times this times this times this times this, and this time have minus 1. So we also have this 0, we have this 0, we have this, we have minus 1. So finally we have this times this times this times this, that is 1, this and this, and that is 3. So that is what we have. We have a 3 by 3 matrix, and we are going to actually find the multiplication, find the impedance of this. So in the impedance, the determinant of this is actually this into you cross this, so this time this minus this, so we're having 9 minus 1. So this have 0 or minus already, we have minus 1. So this is going to cross this, so we have this time this minus 3, this time this, so we have a minus 3 minus 1. So finally we have minus 1 there, multiplying with this time this time this. So that will be minus 1 minus 3, that it will be 4. Minus, so this time this, that is 1. This time this minus 3. So minus 3, we have 4. So we have 3 times 8 and plus, okay, minus 4. We have minus 4. So 3.3 times 8 is 24. 24 minus 8. So the determinant, which is the means of finding the number of trees, is actually 16. So the number of trees that is possible from the graph of this circuit is actually 15. I do want to believe that my viewers have benefited from the video. I want to say that you should try your hand on finding the number of tree that is possible in this video. The number of tree that is possible in this graph. This is a circuit. This is your resistor. Resistor 2. Resistor 3. Resistor 4. Yes, this is VS. So you have to draw the graph and also let us know the number of trees that is possible in this graph. Thank you for listening.